All right, so the next part of this section is just looking at different conic sections. I did add a line in here too, which isn't really a conic section, but it does happen to show up quite a bit, so we're throwing that into it. But we're going to solve a set and find out how many times they intersect, which is the same as how many solutions do they have. So if you notice in this first, the parabola and the circle cross twice, so we have two intersections or two solutions. We could end up with no solution. We could end up with 4, or in this example we have 1. Now it looks like I skipped 3. That is still something that could happen. There's lots of different ways it could happen. You might have a circle with a hyperbola that crosses there and here and here. So you could have 1, 2, 3, 4, or no solutions. Alright, so let's actually try to solve these. We're going to bring back some algebra, some substitution and elimination. So, if we look at this on the right, notice there's nothing squared, which makes this a line. If we look at our function on the left, we have x squared plus y squared with the same coefficients, which makes that a circle. Good practice. Alright, we're going to use substitution because we can take what I put in the green box and I can substitute it in for that y. So I'm going to rewrite this formula on the left, x squared plus, instead of writing y squared there, I'm going to substitute it in with my negative 3x plus 10. Now, since that is squared, I'm going to write it twice, and I am going to FOIL it. Now, if you don't have to write this out, if you can just FOIL it by looking at it, by all means, go for it. Alright, so I just FOILed this out right here, and I got 9x squared minus 30x plus 100. So if I start combining like terms, I get 10x squared minus 60x, and I'm going to go ahead and set it equal to 0. So I'll subtract 10 from both sides, so I have plus 90. Now I'm trying to solve for x. Since there's x squared, I could get two answers, so I'm going to factor out the 10, so I've got x squared minus 6x plus 9, and I'm going to factor this. If it does not factor, remember you can always use the quadratic formula. Now at this point I'm going to set everything equal to 0, that 10 doesn't matter. I've got two of the same factors, which is just going to give me x is equal to 3. Now, I need to plug that 3 back in. Now what you're going to want to do to find the y value is you're going to want to take your x equals 3 and you're going to want to substitute it back into the other function. So I've got y is equal to negative 3 instead of x. Now I've got a 3 there, plus 10. Oops. There we go. So I've got y is equal to negative 9 plus 10, so my y value is 1. So these two graphs will intersect at the ordered pair 3, 1. So they intersect at 1 point. Alright, let's take a look at this next one. So here we've got our function on our left has an x squared and a y squared with different coefficients, so that's an ellipse. And on the right side we have only one squared, just y squared, so that's a parabola. Alright, so on your notes it is saying to go ahead and solve this by substitution, so let's go ahead and get the x value by itself. I'm going to go ahead and add x to both sides. I've got y squared is equal to 5 plus x, and then I'm going to go ahead and subtract my 5. Alright, so I've got x now is equal to y squared minus 5. So I'm going to take that y squared minus 5 and I'm going to replace it right there for x squared. I just substituted in y squared minus 5 for x squared right there. Alright, first I'm going to have to FOIL out the y squared minus 5. I'll write it out twice first and then I'll go ahead and FOIL it. Now I'm doing y squared times y squared, so I'm going to get y to the 4th. Minus 5y squared minus 5y squared will give me minus 10y squared. Negative 5 times negative 5 is plus 25. Next I need to distribute this 5 to everything. And next I need to combine like terms. So I end up with 5y to the fourth minus 25y squared, and my 125s will cancel out. So at this point the only thing I can do is take out a GCF, which is 5y squared, and I'm left with y squared minus 5. Now, since I've got two y squareds, I could end up with actually 4 answers. So if I set 5y squared equal to 0, divide by 5, I'm just going to get y is equal to 0, because I can't do plus or minus 0. If I do y squared is equal to 5, when I square root this, I actually get y is equal to plus or minus the square root of 5. So I have to plug all 3 of these into my other function. So let's start with the 0. I'm going to come back up here, and I'm going to replace the y with 0. So I've got x is equal to 0 squared minus 5. So that one's pretty easy. X is equal to negative 5. So my first answer here is when x is negative 5, y is 0. This is my first answer. Now I need to go ahead, I'm going to plug in radical 5. So I've got x is equal to radical 5 squared minus 5. Well, the square root of 5 squared is just 5, so x equals 5 minus 5. X is 0. So when x is 0, y was radical 5. There's my second point where they intersect. Now I'm going to plug in the negative radical 5. So x is equal to negative square root of 5, all of it squared, minus 5. And again, I'm just plugging it in from right there. I've got x is equal to 5 minus 5 again, so it's 0. So my third intersection point is 0, negative radical 5. If you wanted to, you could have clumped these two together and written 0 plus or minus radical 5. Just realize it is 2 different intersection points. All right. Last one. Now you're being asked to solve by elimination. This is where you want to cross out a variable. So it's not really lined up that great yet, so let's go ahead and look at the first. It has an x squared and a y squared with different coefficients, so that is an ellipse. The second formula here has an x squared minus y squared, so that's a hyperbola. I'm going to rewrite the ellipse first. So I've got 9x squared. I'm going to put the plus y squared minus 90x plus 216 equals 0. So I just copied it the way it was. Now I'm going to rewrite the hyperbola, but I'm going to really try to line everything up. So I've got x squared minus y squared. There's no x term, so I'm just going to jump over and put minus 16 under the 216. Alright, now if you look, you see that the y squareds eliminate. 9x squared plus 1x squared is just 10x squared. I've got minus 90x. 216 minus 16 is just 200. Now, look for a GCF. In this case, it's a 10. So I'm left with x squared minus 9x plus 20. If it doesn't factor, you can't get it to factor. Remember, you can always do quadratic formula. But I know that a negative 4 and a negative 5 multiply to give me 20 and add up to 9. Alright, so I end up with 2 answers for x. That 10 doesn't matter. X is equal to 4 and x is equal to 5. So what I need to do now is I need to plug these in to see what I get for my y value. Alright, so we have 2 numbers to plug in here. Let's start with our 4. So since we've already used both of the equations, it really doesn't matter which one you plug it into. To me, the hyperbola looks way easier, so I am going to plug 4 in for this x squared. So right now I've got 4 squared minus y squared minus 16 is equal to 0. We could have plugged 4 in right here, but that just looks like more work. So I'm all about the easy way. 4 squared is 16 minus y squared minus 16 is equal to 0. Those 16s cancel out, so I've got negative y squared is equal to 0. Divide both sides by negative 1, and square root. I don't have to worry about plus or minus, so y is just equal to 0. So my answer here is when x is 4, y is 0. Now I need to go ahead and plug in the 5. So again, I'm going to use a hyperbola just because it looks way easier. So I'm going to plug in 5 where I see that x squared. 5 squared minus y squared is, minus 16 is equal to 0. 25 minus y squared, I'm going to add that 16 over, equals 16. Subtract 25 from both sides. Alright, so I got negative y squared equals negative 9. Divide both sides by negative 1 to cancel out those negatives. Square root both sides. Remember, when you take the square root, you have to, don't forget about your plus minus, the square root of 9 is 3. So I actually get two different y values. So when x is 5, y is 3, or when x is 5, y is negative 3. So I end up with 3 intersection points. Alright, last but not least, I want you to give it a try. It's your choice, so you can choose either substitution or elimination. Alright, have fun. Again, I will check this, so don't forget to do it.